Alright, you better have new stuff by now. You've been here long enough. So we are going to start chapter 5. I really did want to start it yesterday. I didn't think that was the way to do it. Yeah, so we'll get into it a little bit today. Things you need to know as we dive into chapter 5. There's some good news, there's some bad news. I'm going to give you the bad news first. Even though I told you I normally don't do that. Here's the bad news. You are not done with triangles. Grown. You are not done with triangles. Thank you. Good news. You do get a slight break from proofs. In fact, your next exam, there are 0 proofs on it. I'm not telling you chapter 5 is easy. I'm telling you, for some of you, the proofs are like the difficult thing. You get a slight break from that, okay? But you are not done with triangles. We do some very different things, okay, in this chapter. Today's not too bad, okay, but there's a couple other things that are going to pop up kind of along the way, okay? So if you're looking at the board, what I want you to really think about is, okay, they're obviously all triangles, but they're showing you very, very, very different things. This might not make a lot of sense. Everything I'm showing you on the board, you might be like, I have no idea what they're showing. As the days unfold, it'll start to slowly get there, okay? Which warm-ups are you going to do? Okay, and you gotta get rolling today. Okay, I want you to go all the way through question 9. Everything on 9 you can handle. Let's go. Come on. All the way through 9. We all right back there? Yeah. Are you sure?
You're dressed like
How did our midpoints go? Here they are right here. How did we do on both of these? A couple of you found slope. That is silly. x1 plus x2 over 2. y1 plus y2 over 2. Do not subtract these. Some of you learned that a while ago. Okay, there it is right there. Couple slopes, couple of distance. Somebody here is going to have to remember the distance formula between whoever you're working with.
So that's the square root of x minus x squared plus minus y1 squared.
How did our slopes go? 4/7 and 3/2? Or 1.5? Yes, good. We're not relearning slope. Nobody here is interested in that. Hopefully somebody remembers how to do distance formula. What? Distance formula. Not yet. Somebody should know it. Can anybody enlighten us with the distance formula? Because you do need to know it going forward. Nobody can enlighten us with the distance formula. One person. Okay? Cam, go ahead.
Square root of x1 minus y1 squared plus y1 minus y2.
Okay, I think you said x and y together in the first one, but I think you just meant the x's together. Right? Okay. Here's your distance formula. You do need to know it. I did tell you on that one exam, not the one you just took, the one before, and let a couple things slide. Yeah, that doesn't happen going forward. Remember, it is the Pythagorean theorem. Okay, but the difference in the x's squared plus the differences in the y squared, add them together, take the square root. It does say leave it in simplest radical form, which is what I want. Okay, so get those two distance ones done, and then you got the 3 in the grid, then we should be all good.
Use your calculator.
No calculators needed or used right now. Oh, you're fine.
How much is this? What's 256? What's that? No, it's not 15. That's so good. It's 256. And that's what you
Anybody actually get the square root of 65 for the first? That's on a couple pages. Now the order doesn't matter. I feel like a lot of you need to see this based on what I just saw. The order does not matter. It's kind of like finding slope. So I can either do -4 minus 3 squared, because it doesn't matter. The square is going to turn it positive. Or I could do 3 minus -4 squared. But ultimately, what you end up getting in there is -7, I put the square root in there, squared, and 4 squared. Okay, now when we did distance formula a while ago, some of you started well, then you started doing illegal things. There are no shortcuts. You have to do this difference, square it, do this difference, square it, add them together, and then take the square root. When we did this a while ago, some of you were trying to take way too many shortcuts, and it turns out they don't super work, okay? So let's look at the second one. I think a lot of you need to see this. Okay, so I'm going to go 7 minus -5. So what is that? 12? Hello? Squared. Now I need to go in the same order. 10 minus -8. 18 squared. You can't try to take a shortcut from here. It's going to lead to pain. yes, you need to do 12 squared and 18 squared. You're big kids, you're in 8th grade, you can handle it, 7th grade, whatever. Okay, you can add them together, and when you add them together, you actually get, I believe it's 468. Turns out, though, you can pull square roots out of that. I don't know if anybody knows what comes out of it. It's a big one. Cece, do you know? Ooh, it's a little bit bigger than that. Jazzy? 36. 6 root 13. Now, I can tell some of you are sleeping because it's been like a week since we really started to do your stuff. Others of you, you never had this down. Okay? I'm giving you a warning. Distance formula is coming back. So we wrote it on the board. Cam gave it to you. I can point it back to a couple weeks ago. There are no shortcuts. It is difference in x's squared, difference in y's squared, add them together, and then take the square root. The first one, there's nothing to simplify. Yeah, 468, rough on the first day, but whatever. Okay, deal with it. You can handle it. Okay? Now this stuff should be quicker. Just take literally 1 minute to either finish this, start it, or just check what you have, because this doesn't take very long. Let's go quick. If you have it, just verify your answers very quickly. All right, a segment that lies on the x-axis. Let's go, Ronan, hit me. DC. DC is your only answer, or CD. Some of you, again, grading your test, you're getting sloppy. Line segments still need the segment notation. Okay, a segment that contains the point 0.04 is a couple answers to this one. Sari.
We said just segment AB.
But couldn't it also be AB? Yes. Okay, please have both of those answers. A segment whose endpoints both have an x-coordinate of 3. Jazzy. EC is your only answer to that one. Because they need both endpoints to have an x-coordinate of 3. These do. This has 1. This has 1. They need both to have an x-coordinate of 3. PC's only option. Okay, cool. Now, you might be wondering, how on earth does this relate to triangles? Because you said we'd be dealing with triangles. You will see as it all connects. Okay, so we're going to talk about mid-segments. I don't necessarily know if mid-segment is a word you have seen in math before. Is it? You've seen midpoint. Mid-segment might be new. A mid-segment of a triangle is a segment connecting the midpoints of two sides of the triangle. So if we take a look at this picture, and then again, that, not loving it back there today. That picture I showed you earlier with a bunch of drawings on it might make more sense a little bit later on. They're claiming this is a mid-segment. How do we know this is the midpoint? Because what did they mark? Is this the midpoint? So this is a mid-segment, okay? It connects those two. Okay, so if I go back to this weird picture, see if you can spot any mid-segments. Talk about it as a table. Can you spot any mid-segments that you feel pretty good about? That connects two midpoints.
A2,
A2O.
Wait, no, A2, O, and A3, that triangle.
Yeah.
There's a mid-segment. The red line is a mid-segment.
Okay, now, there's not as many as you think. You might think, well, the first picture, there's like a bunch of them. Actually, are there any in the first picture? No. Are there any here? It's a yes or a no? No. Are there any here? No. There are not any that directly connect one midpoint to another, even though they split it here. Are there any here? Yes. Okay. They go through. Okay. If we look here, you can spot a couple. Okay, but it's apart. So there's different things though. Like this has a right angle. This has an angle bisector. These meet in the middle. Okay, so they're all going to come out. Okay. Now, where have you maybe seen a mid-segment before? Maybe something like this. Okay. So what I want you to do is, I think you should have couple of drawings right there. Okay, after 10 and 11. I want you to see if you can draw in mid-segments, as many as you can, on this guy, and that guy. I drew something like that. Yes.
It is right, just because it's
These.
crooked doesn't mean it's right.
They don't connect in the middle at a point. They go from one midpoint of a side to another midpoint of the other side. Okay? Bada bing. Bada boom. Okay. So here's where you should have ended up. How does it look? Good? Not good? Remember, it's got to go from one midpoint to the midpoint on the other side. There's limited options, okay? Do you notice any kind of relationship at all?
Because low key does the same.
Not low key does nothing for me.
It's like,
seriously.
it's the triangle.
Layla. Same triangle but flip. That's interesting. Anything else?
It's like,
They are similar. It's exactly what we were going for. They're similar triangles, okay? And in fact, tell me if this fraction means anything to you in all of them. It should, okay? Similar triangles, and then each of these guys right here, 1/4, okay? So there's only limited options here. You need to go from the midpoint of one side to the midpoint of the other, okay? That's good. I have another question. It's going to come up in a couple minutes. Does anybody see anything parallel? Okay, you will. You will. Okay, cool. Now, where might you have seen these before? Okay, I'm just not sure. Has anybody ever seen a fractal before? You heard of a fractal?
we did.
You took Algebra 2 with me. This is actually a homework question you had last year. It was like one of the very first weeks of school, okay, where I gave you patterns kind of like this. If you've never seen it before, okay, a fractal is the idea, it's like an iteration where every single one, it splits it into further and further patterns. It's really just connecting the mid-segments of them, okay? There's this famous one, okay, it's called Sierpinski's triangle. Okay, that's actually connecting a whole bunch of mid-segments and creating more and more and more. Okay, what we do today with them won't actually be that bad. Okay, but okay, when we're looking at these, okay, we're going to need to know what mid-segments are. So I wanted to talk about the vocab first. Why don't you answer these two questions very quickly on your own, see if you can get them right based on what we just talked about. You're circling the options. Okay, only one of them is a correct statement. Make sure you pick the correct one in each one. Then we'll talk about like what they actually give us. All right, so circle the correct statement in each one. They start with a mid-segment. This one, it says, connects the midpoints of two sides of a triangle. This says connects a vertex to the midpoint of the opposite side. That's actually something different. Shouldn't it be this one? Yes, okay, good. So mid-segment right here. This is actually still a thing, just not a thing today. And then finally, a triangle has exactly one mid-segment. Gosh, I hope not. I just drew a bunch. That would be weird. Isn't it 3? Okay, sound good? Now, that actually leads to our first theorem of chapter 5. Okay, and I think you'll like the theorems a little bit more in this chapter because remember, you're not going to be doing quite as many proofs. So it's going to be more of a just do it and get the answer, but you still need to know this. Okay, theorem 5.1, the triangle mid-segment theorem. If a segment joins the midpoint of two sides of one triangle, then the segment is parallel to the third side. Let's fill that in first. And let's show what we mean by it. So I asked a minute ago if any of you saw the parallel nature. Some of you put your hand up. I want to know if you see it anymore. So if we have a mid-segment, let's pick this one. Is there any parallel? Let's keep going. Okay, let's go. I like the paintbrush. Okay, so if this is a mid-segment, is there a parallel side? And then for the last one, we need to go green, right? Tis the season. Okay, mid-segment, parallel. Does anybody want to just go for the gold and give me a guess, okay, with the relationship? It's half its length. Half its length. So in that particular diagram, the little green is half of big green, little red is half of big red, little blue is half of big blue. Okay, that's why I color coded them as such. Now you need to know that it's the mid-segment, okay? You need to know. Now you don't need to, this is actually important, you don't need to prove parallel nature. Remember, we spent all that time proving things were parallel. They're actually telling you, if a segment joins the midpoints of two sides, then they're parallel and half its length. So you're not going to have to draw it in and then also prove it's parallel. If it's connecting mid-segments, then we're good to go. Okay? So let's actually fill some of this stuff in. I want you to take a look at this particular diagram and see if you can fill in these guys and just look at it carefully. Make sure you're in agreement with them. Go ahead. Just smart. We'll start small. Then we'll look at some more involved questions. Okay. Now again, the diagram being marked is very critical, okay? So let's start with our if column, okay? So let's go, Sarah, what were your ifs? If, which is it, everybody? Hello? Yes. And, go ahead. Then, let's go, Isaac. Thank you. Good fix. And then? You actually don't have to say segment because it's the measure, but it is in fact DE. So there's no numbers in this diagram, but there will be pretty soon. So what are you checking? That this is the midpoint and this is the midpoint. That means DE is the mid segment and it's parallel. So if I gave you any value, I could make one up. Okay, if AB was 20, automatically, what would DE be, everybody? Perfect, okay? So that's how you're going to use the theorems a little bit more in this chapter. I think a lot of you will like it, but, you know, the diagrams do get a little bit more involved, okay? Lastly, before I have you just try a couple things on your own, this is where the coordinate piece is going to come in. Your ability to find slope and find distance, okay, can't really waver. Okay, so right now you're given that particular triangle. They want you to draw in RS. So draw in RS. Pretty good out of me. Now right now they're not making you prove it. I could easily make you prove that RS is in fact the mid-segment. You know how you would have to do it? You would have to find the distance of this and the distance of that, show that they're the same. Distance of that and distance of that, show they're the same. That's later in the chapter, okay? A little too much for today. Right now, we're just going to go ahead and say right now that RS is in fact, just based on what we can see, the mid-segment of triangle ABC. So what do we know now? It's what? Parallel to AC. And RS is equal to 1/2 of whatever, in fact, the length or measure of AC is. And if we were to draw in another mid-segment, let's say we were drawing ST. And let's think everything we know about ST. There are two things we should know about ST. What's true about it? Two things. Layla, give me one. Well, okay, assuming that it already is. So we're going to say ST is parallel to, did you say BC? Okay, BC, which is good. And then Casey, what else is true about it? Okay. Questions like this are great because I'm not making you prove it's a mid-segment. I would make you prove it with the distance formula, but, you know, a little bit too much for today. Okay? One thing's my only comment before I have you try a whole bunch of questions. I find it helpful to just do a little bit of outlining. So if I think ST is my mid-segment, I like to just do this just to know who's parallel and who's half of what. Okay, just as a thought. Okay? So what do you have right now? I'm going to turn you loose on a good bit of questions. Okay, not all of them though. Okay, I want you to work this question. It does say to draw a diagram. I think the diagram is extremely helpful. Then a bunch of questions like this. Okay, I think you're going to do well with them, but don't kid yourself. If somebody says the answer, make sure you know exactly why that is the answer. Make sure you can process the diagram. Okay, I want you to go all the way to here. I want you to stop when you get to here. Okay, go ahead, work on these together. I think it would be good. Okay, stop when you get to this particular question. Looking at a bunch of your diagrams, it doesn't matter how you draw the triangle. Like I drew an obtuse one, it does not matter. A lot of you are missing your marks. You need the marks, otherwise how would I know that it's actually a mid-segment? So boom, boom, boom. I don't doubt your ability to get the questions right. Just no matter how you drew your triangle, please put your tick marks in. You have to. Yep.
I didn't see the first.
What?
I don't even have any in my defense. I
What? And AD is 6. Yeah, but 6.
Wow. Check.
Oh my god, this is on the iPhone.
Yeah, you go to. Stop when you get to this question. Where is it? Ah, this is the question where I want you to stop. You can keep going. There's a couple more on your page.
Hold on, this is order. But like if it's a what? I don't know why.
Really interesting to see some of the craziest kids in our grade learning too.
Couple more minutes. A lot of you just flipped the page, which is good. Top question.
I was just putting that in my head. I don't
Final minute there. A lot of you are on that last question. You should be working out. If you're done, just hang out. We'll get there in a sec.
I'm not gonna read these.
I'm gonna come for this one.
It was like
I can't.
I honestly, Eagle, I'm sorry. I mean, you guys,
We're about to disband.
Oh no, I would have not. I'm looking at
Okay, so let's go back to this question. Very few of you put the markings in. Be honest. How many of you did not originally put markings in your diagram? Come on, it was a bunch of you. So. Here's the problem. If you don't, you can't use the theorem. You have no proof that they're mid-segments. Once they are mid-segments, then they're parallel, then you can use a half. Okay? Let's talk notation. Okay, because a lot of you are now putting segment notation when you don't need it. Okay, let's get some answers out there. Who's AB parallel to? Yes, you need segment notation because we're not putting measures in. Okay, who's CB parallel to? X, Y, Y, X, whatever. And CA? Okay, good. Good. Do not put the mid-segment coordinate in your answer. So for example, in the last one, don't put YB. That's going to be marked wrong. Okay, but you needed those pieces. Now this guy right here, I like this question. In triangle XYZ, that's the big one, M, N, and P are midpoints. It's not required that you mark these. I don't think it's a bad idea. If they tell you that they're mid-segments, okay. I think it's a good idea just to keep it straight. The perimeter of triangle XYZ is 120. Find NP. So it would probably be helpful to know that NP is parallel to who? Hello? Okay. Somebody want to tell us how are you going to complete this problem? A lot of you did it. How are you going to actually work through the problem? I should be able to pick anybody here. Sawyer.
You have to, so like, it's 1/2 of each side, so you have to double it and then put them on the corresponding.
So let's be more specific. So who's 22 half of?
X or Y.
So that's 44. What else?
24 and then you add them together and subtract them.
And what do you get for your missing side?
28.
So then what is NP? Good. Okay. Do you put segment notation above that? No. Because they want the length of NP, the measure of NP. So you don't actually put the segment notation, little tiny stuff. Okay? Because they want the length of it. Okay, so it's 14. Okay, well said. Okay, so I like that question. Let's look at this guy. Okay, now you start out by just filling in information that they gave you, but you do know that they're all mid-segments. Boom, boom, boom. So my parallel natures are in. Okay? So AD is given as 6. That guy's right there. And what else is given? DE. This guy is given as 7.5. Okay? Caleb, what do you have for each of these and tell me why?
This one,
Yes.
for DB, I have 6
How do you know it's 6?
because it's half of AB.
Oh.
Because no, AD is,
That's how I would argue it. They're marked the same. Okay? So that gives us DB.
AC is.
Why do I hear anybody else talking besides Caleb? Go ahead.
AC is 15
Because
DE is half of it.
since that is the mid-segment and that's parallel, it's half, so that's 15. Okay, good. And then we're on to our last one, which is AB.
AB is 12 because 6 was 6 equals 12.
Yeah,
Because
they're-
congruent.
They're given right there, okay? And then that leads to our last piece, which is EF.
EF is 6 because it's half of 12.
Perfect, okay. There's your 12. Manageable question. Very manageable, but you don't want to get lost in the work, okay? Now, you get to this question, I heard some of you talking. You're like, okay, I'm doing fine. And you're like, wait, we did not talk about angles at all. What does he expect us to do? Remember, you do know some things because of parallel, okay? So are we given any mid-segments right now?
Yeah.
We are. What are we given? Okay, we're given NM is a mid-segment. How do you know? Because
Yeah.
they're marked as midpoints. So, who is NM, Conlon, parallel to? By definition, if it's a mid-segment, it's parallel to CV. So actually, how many of you noticed? Bada bing, bada boom. Yes, good. What are those angles called? Does anybody remember? Yes, corresponding. Good job. And actually, you know a little bit more. You also should know, I mean, I could just fill in the diagram, I can't remember what they asked, but you should also know this is 75. Isosceles triangle, which by the way, some of you fell in love with isosceles triangles in your chapter 4 test, and they did not love you back. Talk about that when it happens. So I get 75, 75. This is also 75. What's the vertex angle have to be?
30.
Good, okay? Okay, ooh, measure of angle A equals 30. 75s all the way around. So even though we didn't talk about the angles when we went over the theorem, we did mention parallel. Once you have parallel, you're all of a sudden in business, okay? The last question I asked you to do, same kind of idea. If the measure of angle UXY is 60, if these are in fact mid-segments, and they're not marked, but X is the midpoint of UV, Y is the midpoint of UW, they are, I already know what's coming with this. This is 60. This guy, if it's given as 45, then the measure of this guy up here is also 45, and then I can progress. Okay, then they all of a sudden go through lengths. So if XY is 50, what's this guy kicking down here? 100. Okay, and then again, if UY is given as 66, this is another 66, added up, 132. So you should be 132, 100, and then the angle set. Okay, perfect. Now why did I want you to stop here? It's not that I didn't think you could handle this question, but you have to be really careful with the diagram. They want you to find the values of X and Y. This is where I think you want to really, really focus in on who is parallel to what. Let's verify everything is in fact a mid-segment. Mid-segment? Okay, that's good. Mid-segment? Good. Okay, doesn't mean you're going to need to use them all because boom and boom. Okay, but this is where I like to, you don't have to do it the same way I did, but I like to really highlight the pieces I think are going to help me. So that guy is half of what? That guy. So that might be something that I can work with. Then it's just algebra. How do I write that as an equation though? Y equals, come on. Or what could I have written? These are equivalent. It doesn't matter if you write this one or you write this one. They're going to help you out, okay? Is that enough information to get the answer? No, but I can look across at another relationship and then I could go. So now I've used these guys. What do you think here? And then what's the relationship there? Either X is equal to what?
1/2 3x minus x.
Or I could use what?
2x is equal to 3x minus
Oh, wait a minute. Is that good?
Yeah.
Can I get anything off of that?
Yeah.
Yeah, no lies at all. Okay. We could quickly solve this guy. What's X?
6.
6. And then I could pick either of these and get Y. I think maybe I should use this one. No one's going to say yes?
I can see it.
Plug in 6. So what do you think? 6 times 2, 12 plus 1, half of it was Y.
6
Okay, good. Now, on a test, which I know a lot of you are like, your geometry tests have been ones you can finish and check. You could easily check this. Yeah, you could leave it. You might get it right with 6 and 6.5. I don't know why you wouldn't plug everything and then it lines up. So if X is allegedly 6, 3 times 6, what's that? Minus 6. Does that line up? Okay. What's Y allegedly? Isn't X still 6? 13. Does that line up? Okay. A lot easier to check this. Now I know the proofs that you just did, those maybe were a little bit harder to check because you got to be on the right path. This is a little bit more manageable. Okay. My only advice is a question like this is very doable. Don't be above highlighting. If you need to highlight to get the correct size, that's fine. Don't get lost in the weeds, lost in the diagram. Okay. Now the last question I want you to work on as a group. This is more along the lines of what a proof in this chapter looks like. You're given a couple coordinates. You're given some information. You have to show kind of algebraically, so to speak, with things we've talked about, this and that. Okay, so I want you to talk about how you're going to do it. Just take it in stride. Start by plotting these, start by following their directions, and then see how you're going to show these things. It's not a 2-column proof. It's more like a demonstration. Okay, go ahead. It's our last thing here.
I knew that.
Yes, we should know everything I'm asking for. You do know how to show me the things I'm asking for. Give yourself some credit. Mine match up with yours very easily. There's like no chance you're done with this already. You have to actually show these things. In fact, a lot of you didn't even write down the coordinates of the midpoint. Good luck. Yeah, this is coordinate geometry. It's not a full like 2-column proof. It's like you have to show and demonstrate. Yes. I kind of told you this was coming earlier. I gave you a little preview. How do the coordinates of the midpoints look right here? I got h to be -2, 3. And I got j to be 3, 4. Now you can't just draw it in and put the markings in. That's not showing anything. So you should know this, but we will remind everybody, because somebody's going to tell us, how do you show that 2 line segments are parallel? Ronan, you have to prove to me they have the same slope. Don't tell me you can't do that. I'll send you back to Algebra 1. Okay? How do you show that the length of HJ is 1/2 the length of GF? Distance formula. Thank you. You got to do these 2 things. It's manageable, okay, but not going away. Welcome to my world when people think they're done. It's either this or 2-column proofs. Coordinate geometry is a little bit different.
What do you think? Yeah, I am good. I thought it was like this for. That's already over. That's right. I know. She's making me wait until like January to see my fucking thing. She's gonna wait and I know.
You do have to find the distance of HJ and GF. You can't find the distance of one and not show me this. Half the distance of the other.
What is it? I'm already going to say it.
The slopes, how many of you got them to each be 1/5? Put them up, crowd. We got slopes of 1/5. Do not lie and tell me you don't know how to show that two segments are parallel. I seriously will send you back to Algebra 1, okay? Now, distance formula, you need to get that under control a little bit. I'll give you another minute, but you have to do both of them. You have to show me that this distance is half of this, or alternatively, I guess you could show me that GF is equal, or that HJ is equal to what? Double that. You could do either one. Yeah, I'll give you a second, but I'm looking for particular numbers. I'm looking for particular numbers. What you going to do in your work? I got it. Find out, I guess, if they call for it. If they call for it.
Also, how would
Boy, some of you can't handle the distance formula, which was a problem a little while ago, too. There's the length of HJ.
I'm not live. He probably told you guys he was wanting to and then he changed his mind. The cap went to like period 5, and he doesn't want to add.
Okay, and the last one. So HJ, I worry about this group. You'd be surprised. I would say only a third of you actually can do the distance formula. You're just not focusing. Okay, we did this a while ago. Okay, so I did HJ first. I got HJ to be the square root of 26. You cannot just then say it's double. That's not showing anything. That's just guessing. Also, it might not necessarily be true. So you do have to go through the calculations. Yeah, it'd be nice to have a calculator, but you don't need it. You really don't need it. These numbers aren't that bad. You do get the square root of 104. But the square root of 104 definitely simplifies. What goes into it? 4. Doesn't it? 26 times. 4 doesn't come out to play. 2 comes out to play. Please put a little conclusion there. ... Therefore, HG is equal to 1/2 GF. You don't have to write QED. I guess you could. I wouldn't necessarily mark that wrong. Just get a little break from QED. Okay? We'll lie to you. Some of you don't think the distance formula is that. Like, it's that. You need to have it down. Okay? You got to focus on it. Yeah. Yep. And you are doing the answer. Okay. All right, go.